Welcome. This talk is about FFF, a fast, type or assistant file search toolkit that works for humans, Neovim plugins, Node or Bun SDKs, and even AI agents through an MCP server. First, let's describe what FFF is. It is not a command line tool like ripgrep or FZF. It is a library that lives in a long-lived process. By keeping a persistent index in memory, it can answer thousands of searches per second without the overhead of forking, setting up a new process, or rereading, JIT-ignore in each call. On a large Chromium-side repository, it turns in an second ripgrep run into less than 10 milliseconds. FFF has a core written in Rust, wrapped by a tiny C library that can be bound to any language. That makes it easy to use from C, C++, Zig, Go, Python, or JavaScript. The Node and Bun SDKs expose a pleasant API for your IDE or AI agent, and a lightweight Neovim plugin gives you real-time fuzzy file picking inside the editor. The most important features are: for sensor ranking, each file has a usage score that is updated when you open or edit it, and search results are sorted so that files you open often rise to the top. This behaves like the recently opened list in Visual Studio Code, but applied to every search type or assistant fuzzy matching. Both path and content searches use Smith-Waterman scoring, and the path search uses a SIMD-accelerated algorithm derived from the library Frisbee. That means you can type a misspelled file name and still get the right results. 3 content arc modes: literal, fast memem, regex, the Rust regex crate, and fuzzy, Smith-Waterman linebaline. When a literal search returns 0 matches, it automatically falls back to fuzzy multi-pattern or search. A SIMD-based ahocoric engine can search for many identifiers at once, which is faster than running many separate ripgrep invocations. Background file watcher that updates the index when the file system changes, so you never pay for a full rescan on the hot path. Git status awareness. Each result carries flags for whether the file is modified, staged, untracked, ignored, etc., without spawning the Git binary. The watcher uses libjet2 internally. Definition classification. On the Rust side, a byte-level scanner tags lines that look like struct, function, class, or other language definitions, so an AI can easily jump to definitions, optional contexts, pagination, and absolute path disclosure, all available as fields in the returned data structures. How do these features break down into the different layers? At the lowest level, you have the Rust crate FFF search. It implements the index, the fuzzy search algorithms, the background watcher, and all the logic described above. On top of this crate is the C interface, a header file and a shared library that expose all the functions with a stable ABI. That layer is what the Node, Bun, and C bindings call. The Node and Bun SDKs are thin wrappers that expose a file finder class. You create a single instance pointing at a directory, wait for the initial index build. You can set a timeout, then call methods like file search and grep. Each method returns a promise that resolves to an array of objects that contains the relative path, line number, line content, git status, frequency score, and so on. The Neovim plugin uses the same library under the hood, but presents it as a picker. You can press shortcuts to open the file list, perform fuzzy grep, or select multiple files to send to the quick fix list. The plugin also supports a modes setting. You can enable only the tools, replace the built-in grep with FFF, or keep the default UI. The MCP server is the piece that plugs FFF into AI agents. The server exposes a simple text protocol that lets an agent send a query string and receive a JSON array of results. The agent only needs to know the host and port, and the server will handle all the plumbing. The server also ships command line tools like fgrep, find, and FFF multigrep that can be used directly from the shell. Now, let's look at some practical examples. Installing the MCP server for Linux or Mac OS, you run a single curl command that downloads a shell script and pipes it to bash. For Windows PowerShell, a similar unliner downloads a PowerShell script and evaluates it. The script installs the server binaries and prints wiring instructions for your chosen AI client. Once the server is running, you can tell your agent to use FFF and it will start sending queries through the server. Using the Node SDK in JavaScript, you import the package, create a finder with file finder create base path, process CWD, AI mode, true. After the promise resolves, you can call a wait finder value file search button, page size, 20, to get the 20 most relevant files matching the word button. Or you can call a wait finder value grepjit off the record profile, mode, plain, smart case, true, to search inside the repository for that exact string with smart case handling. When you're done, call finder value destroy to clean up the resources. Using the C library. If you need to embed FFF in a C program, you include the header,